object, and the ray of light is incident on a spherical surface. After that it got refraction. Right? This is the process it is happening. Now the ray of incident, whatever happening, that I put it as a O. It is a touching of spherical mirror M, and reaching after refraction it reaching a point called as I. Okay, and mu1 is a refractive index of medium 1, and mu2 is the refractive index of the medium 2. This is a rarer medium, this is a denser medium, and when a ray of light incidents, then it bends toward the normal, and the point where it hits, I drawn the normal, and that point normal, right? And here the point where it touches is called as C, and the radius of curvature is named from this point, which is nothing but P, we can call it as, right? So from here, this is nothing but radius of curvature, and this is nothing but V, image distance, and this is nothing but object distance. Got it? So I repeat quicker, so that we are going to find out this derivation, mu2 by V minus mu1 upon U equal to mu2 minus mu1 upon R, where mu2 is the refractive index of medium 2 and mu1 is the refractive index of medium 1, divided by R is the radius of curvature, that is the distance between the mirror to the center of the curvature. This is a point now. Now what I do, this refraction on a spherical surface, to find out, we are using Snell's law. At a point M, what it says, Snell's law, it says that we know that sin I by sin R equal to mu2 by mu1. Right? Sin I by sin R equal to mu2 upon mu1. This is a Snell's law. Now, for a small angle of incidence, what happens? Sin I stands to the I, right? And sin R stands to the R here. Got it? Again, see, for small angle, it is if it is I is small, sin R stands to the R if as R is small. Now, therefore, what I write, sin I by sin R, I write, what I write, sin I by sin R, I by R I have taken, I by R equal to, as it is, mu2 upon mu2 is as it is. This I name it as equation number 1. Now for a triangle MOC, what I write, that at the angle of incidence, this angle of incidence is equal to MON plus MCN, right? This is written here, MON plus MCN, this triangle. So that is, I rewrite, as we know, angle is equal to, angle of anything is equal to arc divided by radius, Therefore, this at angle MON, can be written as, this angle MON can be written as MN upon ON plus MCN can be written as MN upon NC. Right? So this I name it as equation number 2. Similarly, I take another triangle. MCI. This triangle. Okay? This can be written as, this MCN is nothing but this is R, angle of refraction. It is angle of refraction. So E is equal to triangle MCN minus MIC will be this MCI triangle, right? So this, angle MCN equal to this angle, that is this angle R plus angle whatever made by this one, MIC, here I have written, that is equal to angle R equal to MCN minus MIC. This is mathematical. So MCN minus MIN, as it is I have written. Why? Because MIC and MIN are MIN are similar triangles. Therefore have same equal angle. Therefore instead of this MIC I have written MIN or MIC I have replaced with so this is replaced with the MIN. That can be written as that is MCN can be written as arc by radius it is, that is MN upon NC that is here. Okay, MCN can be written as MN upon NC. Similarly for the another here with the minus symbol, MIC can be written as MN upon NI. This I name it as equation number 3 and this I have named it as equation number 2. I quick recall that we have taken the two triangles and MOC and MCI, where I equal to MON plus MCN. We know this angle equal to arc by radius, therefore I have taken this equation number 2. For the triangle of the MCI, I have written MCN equal to angle R plus MIC. That is R equal to what we get, this also written, as it is a similar triangle MIC and MIN. I have replaced with the MIC as MIN. Therefore for this, when I apply the triangle R equal to MN upon NC, I get for this, and for this I get MN upon NI. Now when I go for a calculation, so what equation we had? We had from the equation 1 I by R equal to mu2 upon mu1, right? This was the equation number 1. Here it is, right? This equation what I write, that is I into mu1 equal to R into mu2. Now I value from the equation this I substitute here, and R value from the equation number 3 I substitute here. So in equation 1, so what I write, so after substitution what I get, see, that is here I value I have substituted MN upon ON plus MN upon NC here, and this value I have substituted here. Next part is C. Now what I have taken, Mn I have taken a common here. So that Mn after taking common, this will be 1 by On, this will be 1 by Nc, mu1 as it is, Mn also here taken common. So these two gets cancelled. What are the remaining parameters then? It is a 1 by On plus 1 by Nc into mu1 is equal to 1 by Nc minus 1 by Ni into mu2. So in the continuation of this, what I get, if I multiply this, that is mu1 into On, mu2 into this I write here. In the next of this factor, what will happen here? That is this step, mu1 upon On plus mu1 upon Nc, right? So this factor, what happens? This factor equal to mu2 here, mu2 upon Nc minus mu2 upon Ni. Now what I do, I take this factor here, mu2 into Ni toward the left hand side plus as it is mu1 upon On is equal to mu2 upon Nc minus mu1 upon this mu1 upon Nc, this Nc. Okay, this I have taken toward this. Now what I get, that is, what is Ni? So Ni from the figure, Ni is nothing but what? N into I. What is this? It is a V. Therefore what I write, that is mu2 upon v plus what is on. On in the figure, O to the n is a u. Therefore it is mu1 upon u is equal to mu2 upon nc. What is nc? N into c is r. Therefore mu2 upon r minus mu1 upon what is nc? It is r. That is nothing but mu2 minus mu1 upon r equal to mu2 upon v plus mu1 upon u. This is your refraction on spherical surface.